Welcome to all of you. Now we discuss MCQ 2023 paper CC-11 Probability and Statistics Semester 5 CBCS Mathematics Honours, University of Calcutta. Question paper 2023. Question 1a. If probability B equal to 1 by 4, probability of A by B equal to half, probability B by A equal to 1 by 4, then probability of A is now the conditional probability A by B equal to probability AB by probability B. This implies probability A by B half and probability AB by 1 by 4, because probability of B equal to 1 by 4. So probability AB equal to 1 by 4 into 1 by 2. Now probability B by A equal to probability AB by probability A. This implies probability B by A equal to 1 by 4, probability of AB equal to 1 by 4 into 1 by 2 by probability A. Hence probability of A equal to half. Hence the correct option is 2, this half. Next question, question 1b. 2 dice are thrown, then probability of sum of faces equal to 10 is what? When 2 fair dice are thrown, the sample space contains 6 into 6 equal to 36 simple even points, and the event sum of faces equal to 10 for this 2 dice contains the following 3 events: 4, 6, 6, 4, 5, 5. Hence the required probability by classical definition of probability, these favorable cases for the event A, this event A, say this event A, sum of the faces equal to 10, divided by number of simple even points in the sample space, this is equal to 36. So this is equal to 1 by 12. Hence correct option is 1 by 12. Next, question 1c. The probability density function is given by fx equal to x bracket 1 minus x when minus 1 less than x less than 1, fx equal to 0 elsewhere. Then the value of the probability of the event x greater than half is what? Now probability of the event x greater than half, that is equal to integration half to infinity fx dx. Now this fx probability density function PDF defined for this interval minus 1 to 1, and otherwise fx equal to 0. So for half to infinity we get actually half to 1 x bracket 1 minus x dx, and for the other interval 1 to infinity and 0, and so this integrating this x square by 2 minus x cube by 3, lower limit half, upper limit 1, and after simplification we get this equal to 1 by 12. Hence the correct option is 1, this 1 by 12. Next question 1d. If yt is the characteristic function of a random variable x, then the characteristic function for this x by 2 minus 2 will be what? We know that an important property for characteristic function, if phi t x, actually this is the characteristic function for the random variable x. So we x denotes the suffix x denotes the for the corresponding random variable x. Phi t is the characteristic function of the random variable x. Then the characteristic function of y equal to ax plus b, where a, b are real constants, is given by phi t y equal to e to the power I bt phi atx. This is the characteristic function of x and this is the characteristic function of y. Now here the random variable x by 2 minus 2. So comparing with ax plus b, we get a equal to half, b equal to minus 2. So putting this b equal to minus 2 and a equal to half, we get this phi t of y equal to e to the power minus 2 it phi t by 2 of x. So the correct option is 1. Next question 1e. If the joint PDF of the two-dimensional random variable xy is given by f xy equal to 1 by 4 when 0 less than equal to x, comma y less than equal to 1 and 0 otherwise, then probability of x plus y less than equal to 1 is equal to what? Here range of x is 0 and 1, so x equal to 0 to x equal to 1. This is the first quadrant, x axis, y axis, this is the origin O, and y this y 0 to 1, so y equal to 0 x axis and y equal to 1 this, and this is the area of this, and probability of the events x plus y less than equal to 1, this is equal to the probability of y less than equal to 1 minus x. So x plus y equal to 1 represents this straight line, this x by 1 plus y by 1 equal to 1. So this is the x plus y equal to 1, this straight line, and this less than equal to, so actually corresponding region is this set region. So x equal to 0 to 1 limit for x, so x equal to 0 to 1, and corresponding y limit y equal to 0 to 1 minus x, 1 minus x, y equal to 0 to 1 minus x, corresponding this strip and this strip moving from x equal to 0 to x equal to 1. So y equal to 0 to 1 minus x fxy dy dx. Now first we f of x defined function this for this 1 by 4 fxy equal to 1 by 4. So put 1 by 4 y, this 0 to 1 minus x, so this equal to 1 minus x and dx, integration 1 by 4 0 to 1. So x minus x square by 2 0 to 1, this 1 this 0 minus put here for x equal to 1, so 1 minus 1 square by 2 minus 0, so this minus 1 by 4 into half, so 1 by 8. Correct option is 3, 1 by 8. Next question F. If the moment generating function of a binomial random variable is mt equal to 2 by 3 plus 1 by 3 to the power t whole to the power 5, then the mean and variance are respectively what? Now we know if x be binomial np variate, this p 0 less than p less than 1 and n is a positive integer, then its moment generating function mt of x is given by mt of x equal to the summation k equal to 0 to n e to the power tk nck p to the power k bracket 1 minus p whole to the power n minus k. The summation k equal to 0 to n nck this p to the power k and e to the power tk, so p e to the power t whole to the power k 1 minus p n minus k. This by binomial theorem, this 1 plus p e to the power t whole to the power n, this equal to 1 minus p equal to q, So this q plus p e to the power t whole to the power n. This is the moment generating function for x equal to q plus p e to the power t whole to the power n for all real t. Now comparing with the given moment generating function, this 2 by 3 plus 1 by 3 to the power t whole to the power 5. So q equal to 2 by 3 and p equal to 1 by 3 and n equal to 5. So again we know that if x be a binomial NP variate, then mean of x small m is equal to np and variance of x is equal to npq. So mean m equal to n into p, n equal to 5 and p equal to 1 by 3, so 5 by 3, and variance x equal to n into p into q, this is equal to 10 by 9. So the correct option is 4, 5 by 3, 10 by 9. Next question 1G. If independent random variables x1, x2, x3 have variance L, actually they are mutually independent random variables, then the variance of the variate 2x1 plus 4x2 plus 5x3 whole divided by 3 is what? Now we know if the random variables x1, x2, xn are mutually independent, then variance of a1 x1 plus a2 x2 plus plus an xn equal to a1 square variance of x plus a2 square variance of x2 plus plus an square variance of xn, where ai's are our real constants. Then variance of 2 by 3 x1 plus 4 by 3 x2 plus 5 by 3 x3 given variate this 2 by 3 x1, 4 by 3 x2 plus 5 by 3 x3. So we get 2 by 3 whole square variance of x1 plus 4 by 3 whole square variance of x2 plus 5 by 3 variance of x3, because these x1, x2, x3 are mutually independent. And so we get 4 by 9 plus 16 by 9 plus 25 by 9 L, because variance of x1 equal to variance of x2 equal to variance of x3 equal to L, given this data is given x1 all variance have L. So 45 by 9 L, that is equal to 5 L. So correct option is 2, 5 L. Next question H. If alpha be a population parameter which is estimated with two statistics A and B, and probability of A less than alpha less than B equal to beta, then the confidence coefficient for the interval estimate of alpha with the limits A and B is what? Now we have the knowledge of interval estimation. Let alpha be an unknown population parameter and epsilon 0 less than epsilon less than 1 be a given number. If there exist two statistics, A, this A is a function of x1, x2, xn random sample, and B equal to B of x1, x2, xn, such that probability of A less than alpha less than B equal to 1 minus epsilon, where this capital A equal to small a of capital X1, capital X2, capital Xn, and capital B equal to B of the random variables of this X1, capital X1, capital X2, capital Xn are random variables corresponding to the statistics A and B respectively. Then the interval, open interval AB, is called interval estimate or confidence interval for the parameter alpha with confidence coefficients 1 minus epsilon. The statistics A and B are respectively called the lower and upper confidence limits for alpha. So here probability of A less than alpha less than beta equal to 1 minus epsilon, then confidence coefficients is 1 minus epsilon. So in this question, probability of A less than alpha less than B equal to beta, so the interval estimate with confidence you limit this, so confidence coefficient is actually beta. So correct answer is 1, correct option is beta. Next question 1I, maximum likelihood estimator MLE of alpha in the distribution function alpha e to the power minus alpha x will be what? Now the likelihood function capital L is given by f x1 alpha, f x2 alpha, f xn alpha. This alpha e to the power minus alpha x, so alpha e to the power minus alpha x1, alpha e to the power minus alpha x2, alpha e to the power minus alpha xn. So alpha to the power n e to the power minus alpha common bracket x1 plus x2 plus xm, taking log on both sides to the base e. So log L equal to n log alpha minus alpha, because log of e is this equal to this, so alpha bracket x1 plus x2 xm, and taking differentiating on both sides with respect to alpha, dd alpha of log L equal to n 1 by alpha minus x1 plus x2 plus xn bracket. So dd alpha log L equal to 0 implies this n by alpha equal to x1 plus x2 plus xm. This implies alpha equal to this n by x1 plus x2 plus xm. Actually this is the sample mean x bar, this x1 plus x2 plus xn divided by m, so alpha equal to 1 by x bar. Again t2 d alpha square log L2 second derivative, this is equal to n by alpha square, obviously less than 0 at alpha equal to 1 by x bar. So maximum likelihood estimate alpha cap, this is equal to 1 by x bar. So correct option is 3, 1 by x bar. Last MCQ, question 1J. For fx theta equal to 1 by theta, where 0 less than equal to x less than equal to theta, to test the hypothesis h0 such that theta equal to 1 against h1 such that theta equal to 2 in the critical region 1 less than equal to x less than equal to 1.5, then type 1 error is what? Now we know the type 1 error is the probability of rejecting h0 when it is true. That is we write this probability of x, this random variable x belongs to the W critical region such that when h0 is true, h0 is the null hypothesis and x the random sample, corresponding random sample. Here W is the set x such that 1 less than equal to x less than equal to 1.5. So W bar is the x such that x greater than 1.5 union x of all those x such that x less than 1. Size of type 1 error, this probability of x belongs to W such that h0 is true. So this 1 probability of 1 less than equal to x less than equal to 1.5 when h0 actually h0 equal to theta equal to 1 given, so we put here theta equal to 1. Now this function limit is this 1 to 1.5, so integration 1 to 1.5 f of x theta, here theta equal to 1, put here theta equal to 1, so integration 1 to 1.5 this equal to theta equal to 1, fx equal to 1 by theta, so theta equal to 1, fx1 equal to 1 actually, so put here this 1, so dx, so x 1 to 1.5 1.5 0.5, so correct option is 1, actually correct option is 1 0.5. Note that the size of type 2 error actually equal to the probability of accepting h0 when it is false, that is when h1 is true, accepting h0 when h1 when it is false, so h1 is true. So actually probability of x belongs to W bar, this when h1 is true, so this is the 1 minus probability of x belongs to W when h1 is true, this is equal to 1 minus W is the region 1 is less than equal to x less than equal to 1.5, h1 is 2, so h1 is the theta equal to 2, h1 equal to theta equal to 2 such that theta equal to 2, so 1 minus integration 1 to 1.5 f x2 dx, this is equal to 1 by theta, so theta equal to 2, 1 by 2, so after simplification we get 0.75 is the size of the type 2 error. Now power of the test, that is beta w, is the probability of rejecting edge knot when it is false. So rejecting edge knot when it is false, that is h1 is true. Actually this is the 1 minus probability of type 2 error. So power of the test is 0.25. So correct option is 1, 0.5 for type 1 error. Thank you for watching this video. This completes 23 MCQ probability statistics paper CC-11.